Scifest. My name is Sarah Kate Sweeney, though most people just call me Sarah. I was the Scifest at CIT winner in 2015, but at the moment I'm in my second year of Physics and Astrophysics in UCC. So first things first, I'd like to thank Sheila Porter for the Trojan effort that she has put into creating Scifest, and also for asking me to give this talk. Scifest has been such a wonderful opportunity for kids like me. It was really what started off my science career, but I'll get to that in a moment. When I was asked to give this talk, I didn't really know what I was going to say. At the ripe old age of 19, I feel like a bit of a fraud to come on here and give you advice. I mean, I'm probably barely older than some of you. But then I remembered where I was when I stood at your place in the Scifest Nationals 6 years ago. 13-year-old Sarah had absolutely no idea what was about to hit her, so I'm guessing that neither do any of you. I'm also aware of the fact that not all of you are physicists, so I am going to explain some of the physics that I study, but I'll try to keep most of my main points as discipline neutral as possible. I'd also be willing to say that a decent proportion of you are going to end up as some kind of scientist. So instead of just telling my story, I'd like to tell you the things that I learned from that story, so that you don't have to fall into the same traps that I did. I don't have time to tell you about every single project that I did because we would be here all day. So instead, I'll just try and condense the main takeaways from the last 6 years into the next 20 minutes. My first takeaway is that there is nothing more beautiful than the pursuit of knowledge. I have been fascinated by the world and everything that it contains for as long as I can remember. As a child, I could seldom be found without my head stuck in a book. I pestered the adults around me with questions that began with a why. My dad is an engineer who has a love of physics, and he heard my questions not as coming from some annoying kid, but from a scientist in the making, and he answered them all. He quickly found that most of them had their answers in physics. For instance, the day that I asked him what rainbows are made of was the day that I learned about the dispersion of light. Or another day, we went swimming, and I asked him why I could kick back in a swimming pool and I could float when I couldn't do that anywhere else. And that was the day I learned about Archimedes and his eureka moment. As I grew, I became interested in pursuing physics as a career. In secondary school, I discovered the world of science fairs. Not to sound dramatic, but this discovery ended up changing the course of my life. Before then, I wasn't exactly a high achiever, or I wasn't very well respected either. I had decent grades, but I was picked on a lot and I didn't have very much confidence. I'll talk about this more later, but as I established myself as a scientist, I started to gain a lot more confidence in myself. So naturally, when the time came for me to choose my Leaving Cert subjects, I chose physics as one of the 7. My teacher was one of the same teachers who brought me to most of my science fairs. I knew she was absolutely excellent, and I was so excited to finally take a dedicated physics class. But a few classes in, I realised that I hated it. The exact same subject that I studied recreationally, and I loved it so much, was now a bore at best, and at worst, incredibly stressful when it came to exam time. Had I wasted my time in preparing for a physics career? Had I made a mistake? Was I wrong about the subject? It took some time and some introspection to realise that I didn't hate physics. What I hated was sitting in a room and being told to swallow a textbook full of long, meaningless words. I hated asking questions out of curiosity and the only answer being, "Don't worry about that. It won't be on your exam." The thrill of the chase for answers was gone, and in its place was anxiety and perfectionism. I did not hate physics. I hated the education system. Now, please don't pick me up wrong. I don't blame teachers for this. They're forced to teach to the test. When a child enters the system, they're shown that the worst thing they could be is wrong by the exams that they have to sit. By the time they're of age to sit state exams, they're jaded and passionless. There's no more interest left to pique. So the teacher's only way to catch a student's attention is to tell them that the content is going to be in the exam. I saw this pattern in every single one of my Leaving Cert classes, and it completely crushed me. That wasn't how I learned physics as a child, and it's definitely not where my passion came from. At the end of the day, all science boils down to the insatiable thirst for knowledge. The thrill of the chase, the weeding out of the dead ends and the misconceptions to, ultimately, a breathtaking insight into the inner workings of the universe. I'm not sure who said it, and I really wish I could quote them, but someone once said that the only difference between science and messing around is writing it down, and this has exactly been my experience with physics. I wanted to make this the first lesson of the talk, not because you guys at Scifest don't already know. I mean, there's a reason that you're here. No one put a gun to your head and told you to do a Scifest project. But it's very easily forgotten. Science is really hard, and our education system does it no favours. This is going to sound ridiculously cheesy, and I know that, but when, not if, you struggle, remember what it is that drew you to your science in the first place. Remember how it makes you look at the world with new eyes. Go outside on a clear night with a full moon, and let the moonlight shine onto your hand. Think about how 10 minutes prior, those photons were generated by nuclear fusion in the sun, then travelled through the abyss of space to the bright side of the moon, reflected off its surface, and broke through Earth's atmosphere, and then landed in your palm. They've come a very long way, haven't they? And then the stars that twinkle around it. That light has taken some millions of years to reach you. You're literally looking up into the past. When you cross a bridge, look down into the river below and marvel at the stunning complexity of its flow. Even our most powerful computers have yet to find a way to model it. Get lost in curiosity at the universe just for the childish fun of it. The world is exquisitely beautiful, and physics is the study of its beauty. Life without this pursuit of understanding, this pursuit of beauty, in my opinion, is a life only half lived. My second takeaway is that you deserve to be here. I was 12 when I first discovered the world of competitive science. My first project was a fun little technology project about QR codes that I did with a close friend of mine. We presented it at YSE in January 2015, and we were highly commended. We had the absolute time of our lives and made so many amazing friends that I still adore to this day. That was where I developed a taste for science fairs. Actually, I should probably say developed an addiction to science fairs. That's a lot more accurate. Walking out of YSE 2015, I took my dad's hand and I said to him, I want to come back next year. Around the same time, my older brother had just finished his master's in music technology. He wrote his thesis about the mathematical basis of music, but he had focused more on tuning systems and the ratios between the frequencies used in each one. As well as being science obsessed, I'm really into music. I play piano and I sing. So this thesis topic was right up my alley, and I got him to send me a copy. I found it very interesting, but it didn't answer all of my questions. He didn't address the issue of timbre, which is why different musical instruments playing the same note still sound different. And that's the origin story of my project, Maths Behind Music, an investigation into the simulation of musical instrument timbres using Fourier analysis. So, imagine the scene. It's Friday morning. It's the morning of my first ever Scifest competition. I was barely 13, which meant that I had two things: freshly put in braces, and also more energy than the Duracell bunny on speed. I had a 20-minute spiel prepared on the intricacies of my project, and I had been questioned rigorously by my dad to make sure that I could handle even the toughest judge. This was my first time at Scifest, so I had no idea what to expect. I had an absolute ball for the day. The award ceremony came around, and my name was called for, firstly, the Maths and Science Prize, and then the Best Overall Project Award. Suddenly I was swarmed with various scientists and journalists, and they were all asking questions and taking pictures, and I was delighted, but I was also quite confused. I had no idea what was happening. I didn't actually think I was going to win on my first go. So then the very next day was a Saturday, and I went up to Birr in County Offaly and competed in my first ever Cansat competition. I was 1/6 of the Munster team. And it was a very tough competition, but in the end we were crowned national champions, meaning that we would go on to represent Ireland in Lisbon the following June. I really wish I could say that I did something cool on a Sunday as well. I desperately needed a lie-in. I don't remember the Sunday after Scifest and Cansat, most likely because I wasn't conscious for most of it, but I definitely remember the following Monday. I got back to school and there was just drama. So bear in mind, for context, at this point I was a geeky little first year who had very little by way of self-esteem. So I walked in and I was immediately had my hand shaken by the vice principal, whose exact words were, and I quote, "Congratulations, Miss Sweeney." I remember how taken aback I was by the vice principal calling me Miss Sweeney. No one had ever called me that before. I go to my classes and every single teacher begins the class by asking me about what had happened over the weekend between Scifest and Cansat. All the other kids, and even the ones I didn't know, were cheering me on. And I mentioned this earlier, but I was picked on quite a bit in primary school. So this is the first time that I had attracted this much attention in a positive way. It was pleasant, but jarring. I started to gain a reputation for being the science kid, but there was still a voice at the back of my head that said, you fooled them all into thinking that you were in any way competent. Don't worry though, they'll all figure it out eventually. You don't deserve your success. So in hindsight, I now know that this voice was imposter syndrome. At the time, I didn't know what that was, but I used to say that I felt overrated. Back then, I didn't know that this overrated feeling had a name, or even that it was a common condition. I thought that it was just me. It's a massive relief to hear other scientists that I admire talk about their experiences with imposter syndrome. For instance, there are some girls in my course who are a few years ahead of me, and I always thought that they were so amazing and I wanted to be just like them. And a while back at a get-together, I heard them all admit that they were fellow sufferers of imposter syndrome. And listening to them was just cathartic. Turns out that I'm actually far from alone. I'm in the company of all of these women who I aspire to be like. So now I'd like to pay that catharsis forward, particularly to the girls, because I know that we are very, very prone to imposter syndrome. You're not overrated. You deserve whatever success has and will come your way. You deserve your place in science. Actually, science is better with you here. So my third takeaway is don't be so hard on yourself. So I know full well who I'm talking to right now. A bunch of overachieving nerds. And I mean that in the best way possible. Like, I'm one of you, just 6 years down the line. It's people like us that get things moving in the world. We're the ones who always have something to prove. We're always pushing ourselves. We expand every horizon that we encounter because that's what we've always done. But there does come a point where you need to realize that you're a human being and you need to eat, you need to sleep, you need to see your friends sometimes. And just because of the way that life is, not everything goes to plan, and that's not a reflection on you. After my maths behind music era, I spread out into a few different scientific areas. So first, I paired up with a friend and did a project on number theory and cryptography. And then I did 2 solo projects on first artificial intelligence and then quantum computing. Now these projects took immense work. I mean, you guys will be no strangers to the amount of work that goes into science projects. To this day, I'm very, very proud of them. But I could never quite replicate the success that I had with Maths Behind Music. With that, I travelled abroad and I met a bunch of amazing scientists and I received some amazing accolades. I kind of just made a name for myself. To this day, that's the project that I'm known for. Meanwhile, just as much, if not more, work went into my other projects. But in terms of awards, they only won a few small things here and there. Now, just to clarify, I don't want to sound ungrateful for any of this. I know that awards aren't everything. They really, really aren't everything. And I love all of my projects like they're my children. Undertaking them were some of the best decisions I've ever made. The things I learned from all of them, I'm still using to this day, especially now that I'm studying physics in college. But at the time, without knowing what I know now, I could not stop being harsh on myself. I pushed myself to keep going and keep working in spite of my school exams getting harder and also my personal life just getting a lot harder to deal with. I gave myself absolutely no leeway whatsoever and I beat myself up over the slightest thing. Actually, I'll admit to you that at one point, I was about 15, I'd say. I intended to present one of the projects at Scifest, but I overworked myself so badly and I burnt myself out so badly that I got really, really ill and I had to pull out. And that was maybe like a year or two after Maths Behind Music. So I think what I'm trying to get across to you with this is don't do what I did. Honor your limitations. There's this really big hustle culture in science that you'll find, and it expects you to lock yourself in the lab or the library and just slave away for hours with no breaks. Otherwise, there is this feeling that you won't make it somehow, that your career is going to be in jeopardy. Now, I'm quite happy to pore over a physics problem for hours, but in recent times, I have also been forced to take some time out. Your career is not in jeopardy because you took a break, I promise. Scientists are people too, you know? I know a lot of the messages that you're going to see out there are going to tell you to work harder and to chase your dreams, and that's great advice. I don't think it's advice that you need. Given that you're here, you're at Scifest, as I said earlier, nobody put a gun to your head and told you to do a science project. You did this of your own volition. You did this because you're a ridiculously hard worker. You know, you're already very driven. You know, I remember the slog that goes into those science fair projects. So I don't think you need to be told to work harder. I think you need to be reminded that you're doing great and everyone is really, really proud of you. And you don't need to be so hard on yourself. It's okay to chill out sometimes. And now that you're here, you're at the Nationals, clearly you've done well for yourself. You get to reap all the rewards of the hard work that you've put in. And, you know, regardless of what happens at the award ceremony, you all have such a bright future ahead of you. You're going to do absolutely amazing. Science fairs are fantastic, don't get me wrong, I loved my time in science fairs. But they are only the beginning of a very, very long journey. So finally, I'll leave you with this one. My last takeaway is don't be afraid to put yourself out there. At the start of this year, I applied to the Max Planck Institute for Gravitational Physics, or the MPI, for a summer internship. I was in my first year of college at the time, and most places don't accept first years for internships because we're clueless babies. We don't know anything, we have no experience yet, so of course. But I really, really wanted to work for the MPI. I've been fascinated by their research for the longest time, but I knew that I was very, very underqualified. I applied anyway because, why not? The worst thing they could say is no. And I assumed that nothing would come of it. Until late March, when I received an email from a guy who turned out to be one of my supervisors, offering me a 3-month summer internship. If it weren't for the pandemic, I actually would have spent the summer in Hanover in Germany, but I had to do it online from Cork instead because of travel restrictions. If I'm being completely honest, when I first saw the email, I thought that it was some kind of a mistake. Why would a world leader in gravitational physics research offer me an internship when I was so obviously underqualified? So I just decided to lean into it. I knew that I was going to have to work hard and learn, and that was exactly what I wanted from an internship. So my project was based on a new set of interferometers. So interferometers are the devices that they use to detect gravitational waves. A new set of interferometers that have been proposed for construction. They have increased sensitivity from past interferometers, so they can detect smaller waves from different types of sources. When they're built, they'll join a network of other interferometers and electromagnetic telescopes. My project was to look into a process called parameter estimation. So that means finding out pieces of information that you want from information that you get from, say, interferometers or also electromagnetic telescopes. You can kind of combine information from different sources. So I wanted to know what you could find out in different scenarios based on what information you do or don't have. I absolutely loved the work. It was very, very hard and it completely broke my brain sometimes, but it was also mind-blowingly fascinating. I had 2 amazing mentors who I got on with like a house on fire, but I won't lie, I did have really bad imposter syndrome the entire time. I was the youngest intern there. There were 4 other interns from all over the world, and I was, by a pretty big margin, the youngest. I know that sounds like a good thing, but I actually it did flare up my imposter syndrome a bit. I don't know if imposter syndrome is ever something that goes away, but it did really help this time around to just recognize it for what it was. You know, I'm young and I'm new to this field and I'm learning a ridiculous amount, and those are all good things. So the main takeaway from this internship that I want to share with you, apart from a desire to go back and do more research into gravitational physics, is that you should never be afraid to put yourself out there, even if you think you're underqualified. There's actually probably a decent chance that you're underestimating yourself. If there's something that you want, maybe it's a scholarship, an internship, a job, whatever, don't be afraid to throw in a cheeky CV. You know, the worst thing that anyone can say to you in that scenario is no, and best case scenario, you get this amazing opportunity. You have nothing to lose and everything to gain, so you might as well just go for it. So that's pretty much it from me. Before I go, I want to wish you the best of luck for the rest of the competition and in whatever career you decide to pursue, scientific or otherwise. You guys have some incredible adventures ahead of you. You've no idea. Thanks for listening.